Unit rate. Do now read the following paragraph to yourself. Use the information in the paragraph to fill in the table and answer the questions that follow. Take a moment right now to pause the video and read that paragraph to yourself. When you're done reading, start the video again. Let's read this paragraph together. If you haven't already underlined, while I'm reading, go through and underline the important information. Wildlife conservations are concerned that the deer population might not be constant across the national forest. Scientists found that there were 144 deer in a 16 square mile area of the forest. In another part of the forest, conservationists counted 117 deer in a 13 square mile area. Yet a third conservationist counted 216 deer in a 24 square mile plot of the forest. Do conservationists need to be worried? Take a moment to answer question 1 on your own. The question is, why does it matter if the deer population is not constant in a certain area of the national forest? So you're thinking about real-world reasons. Please pause and answer that right now. Question 2 asks, what is the population density of deer per square mile? Fill in the table below to find an answer. You'll need to use the information from this paragraph to fill in your table. I'm not going to help you fill in the table because you can fill that out on your own. Let's fill out the vocabulary together. The blank represents the number of deer per square mile. This is a term you should have heard last year in 6th grade accelerated math. The unit rate represents the number of deer per square mile. The next blank, our numbers represent a blank if the unit rate remains the same for all our data points. If our data is proportional, we can also call the unit rate the blank. So this is new content for 7th grade, right? Our numbers represent a proportional relationship if the unit rate remains the same for all our data points. If our data is proportional, we can also call the unit rate the constant of proportionality. It says K in parentheses over here because we use K as the variable to represent constant of proportionality. This might seem silly, but in German, constant is spelt with a K. And for some reason, we've adopted that as our symbol to represent constant across all languages, even though it's not spelled that way in every language. So again, the unit rate represents the number of deer per square mile, and our numbers represent a proportional relationship if the unit rate remains the same for all our data points. So in your example, the unit rate did remain the same for all your data points. You should have found that the unit rate was 9, meaning that there were 9 deer per square mile in this forest. Therefore, the unit rate is 9, and the constant of proportionality is also 9. Please use that information that I just stated to fill in this blank. So again, the unit rate for 1 square mile is 9 deer. So what that means is that there are 9 deer in every square mile on average. And that is a proportional relationship because the unit rate is the same the whole time. So the constant of proportionality is K equals 9. Let's take a look at number 3 and 4. How many deer are there for every 207 square miles? And 4, if there were 486 deer, how many square miles would they occupy? Pause the video right now and answer these 2 questions on your own. When you're done, resume the video so you can check your answers, but please try them on your own first. Number 3, how many deer are there for every 207 square miles? Well, here's what we know. We know that there are 9 deer per 1 square mile. We want to know how many live in 207 square miles. So I'm going to multiply this by 207 square miles. When I do this, my units will cross out. Here I've got 207 square miles in the numerator, 1 in the denominator, and I'm multiplying by 9 deer in 1 square mile. These units of 207, or for 207 and 1, which are both square miles, cancel out. So I can then take 9 deer times 207. When I take 9 times 207, I get 1863. So in 207 square miles, there are 1,863 deer. Don't forget to include your units. For number 4, if there were 486 deer, how many square miles would they occupy? So to do this, I know that I want 486 deer. And because I'm using multiplication here, I want my units to cancel out. So I'm starting by 486 deer, which is the same as 486 over 1. And I'm going to multiply so that deer cancels out. So I know that my ratio up here is going to stay constant for this whole time because I'm dealing with a proportional relationship. So 9 deer is going to go in the denominator, and 9 deer occupy 1 square mile. So this represents my rate, right? And it's okay that I switched it upside down because it's a ratio. I'm comparing two values. For every 1 square mile, there will always be 9 deer. And for every 9 deer, it will always be 1 square mile. So it's okay that I flipped my ratio like that. At this point, let's cancel out my units. Deer is a factor of the numerator and the denominator, so that can cancel out. When I multiply straight across, that leaves me with 486 square miles divided by 9. 486 divided by 9 is 54, and my units that are remaining are square miles. So if there were 486 deer, they would occupy 54 square miles.